Hi everyone, this is Team 18 and we're presenting Power Transmission Design. Team members, Evis, Reyes, Raul, Garcia-Roves, and Elmer, Gutierrez. A little of the background of our power transmissions. Power transmissions has been in the world for a long time, since ancient time. The thing is that nobody knows exactly where it was the first built, so many people are claiming the roots of these systems.
Okay, those are the design requirements for our system. Our transmission power system will be used to medium to low applications, will be efficiency, and the system will experience moderate shock. We use Boston gear taking in order to select the bearings and the gears.
Our team was given some metrics as part of the project. Our measures were 6.5 horsepower, as you can see, a reduction from 720 to 45 RPM, and an opposite direction of rotation between the shaft input and output. But we also were given humidity levels of from 90 to 95 on the operation environment.
We have three alternative designs to manage to accomplish this proposed design for this transmission. As you can see here in the PowerPoint, you have three shafts in this alternative number one. You have two pair of gears and a pair of spool gears. This transmission will have a reduction of a quarter of the RPMs in each of the gear sets.
Okay, this is the second alternative of our project. Basically, this alternative have two bevel gears and 7 spool gears. You can see at the bottom, this is the input shaft, and the other side you can see the output shaft, the second alternative.
We also have a third alternative, which is we took a little bit of different approach. We got a set of 4 gears in series, spool gears. Every one of them will reduce 0.5 from the RPM and the initial bevel gears that we actually use from changing the direction of the shaft.
Our proposed design, after we took all the calculations and we took in consideration all the manuals out of the catalogs on Timken and Boston gears, we decided to pick these gear sets and this alternative because it was it's not that it's the thing is that alternative number one and alternative number 3 were not prepared for this situation, these matrices that we were dealing with. So what it means that alternative number 1, it was failing every time we picked the gear for it due to the short reduction in short place inside the transmission. And alternative number 3 was working, but the thing is that the gears were too expensive due to the size and consideration also the efficiency due to weight of the transmission will be alternative number 2 is the one that is the best.
As you can see, this is design detail for the gears. Basically, we use one set of straight bevel gear ratio of half and 90-degree angle, and we use this set of spool gear reduction of ratio of half each. For the last set of gear, we use one spool gear between them in order to change the direction of the shaft.
Besides details of the gears, we also have some details on our shaft. We have 7 different shafts that we machine from regular steel parts to fit our specification and a specific gearbox that we're building. We also have some material. We also have some design details for our bearings. Initially, we select 2 kinds of bearing to fit our shaft, but for simplicity of our project, we just decided to adjust our shaft to go with just one bearing size, which is the one represented by the 4.
We use simulation software to analyze and prove all the data that we acquire after we picked alternative number 2, and we wanted to be certain that every calculation that we did was correct. Also, we did specifically analysis through the shafts and area of the single components inside the transmission.
Besides doing the shaft and other simulations, we also did our bearings, put them in the SolidWorks and Autodesk Inventor to make sure our bearings will not fail during the operations. Now the next is some material considerations. So as I say, we machine our shaft from regular steel bars. The bars will range in diameter from 2 to 10 inches, and the price will be from $17.65 to $113.67. We also consider cast iron as a second option, and we paid more attention to materials is in a box, because the box is going to be exposed to from 90 to 95 humidity. It's a higher humidity environment, and our metals will be prone to rust. So we believe aluminum would be the best options that will take over will not let the rust take over the box.
We have two short videos to show you how our final assembly looks like. Here we have the input and the output shaft has two pieces of metal, so you can see the relationship between the input and output shaft. As you can see in the picture, in this video, this one is a little bit faster, you won't be able to see, that's why we did the second one. The difference between the output shaft and the input shaft is that this one is a high RPM shaft, and the output shaft is low RPM, high torque, and it's also opposite one to the other. There are many applications for these transmissions. Some of them are used in 4x4 equipment, others are used to lift heavy torques, and many other applications. The main reason that they use this is because they need a high torque transmission to acquire the demands that this system needs.
Okay, for the conclusion of our project, I would like to say that the design specifications for the project were met. The gearbox successfully reduced the RPM from 720 to 45. All components were selected from available catalogs like Boston and Taken, and all the components were tested for software like Inventor and SolidWorks.
Thank you.
Thank you.
I want to add something else. We have done many calculations and many simulations through this system. If you have any question on the presentation, please don't hesitate to contact us through the video forum in YouTube. Thank you.